previous video, we did all the logic to allow our king to castle, which is quite nice, quite good. Now, although it can move to the final position, the rook is not moving with it. So what we're going to do now is exactly that. In our app, TCX, whenever we execute the move, so move piece, we're setting this move history list, changing the player turn and all of that. But most importantly, we are updating the squares with the new piece. So we are saying, okay, piece move to that square and now remove it from this square, which is fine whenever you are moving just one piece at a time. But now we are moving two pieces. So we could say here, I'll create a small if, and again, this logic is growing, so we're going to refactor this and make it slightly better. If this, now let me get here, let's say move dot type equals, as we saw before, let's say here castle king side, we're going to perform something, right? And the same if this move dot type is castle queen side. Okay, we're going to do something around this. Let me adjust the to do here. The problem is, as you probably have seen, is that the move doesn't exist here. We have just the current square and the final square. So this move piece here needs to be updated in order for us to have the move itself. This move piece, looking at it, comes from the board. So let's open our board and see where we call this move piece. Here. So select square, we have the square model. If there's a selected square and it's a valid move, and it's not the same as the selected square already, move this piece, sending the selected square plus the target square. So in our move piece, we need to say, okay, what is the current square? Fine. What is the target square? Yeah. But also the move. We could change this and add this inside our move. We could like send kind of a move history that we were doing before. But for now, keep it simple and just let's send the move. This move is inside this array valid moves. So instead of saying here is valid move, I'm going to create another function here, which is the move itself. So I'm going, my link just changed a lot of stuff here. I'm going to say here get move, return find. Instead of being sum to find, instead of being a boolean, it to be a move model. Because the valid moves, as of now, they are coordinate models, but they need to become move model. Like so. That move is not being used at all, so it can be move model or undefined. And it's not being used, but now we're going to do. So we're going to say here, get move, sending what we need to say, send the square. Okay, like this. Actually, let's make sure that, yeah, this can be undefined. And then the move piece here will receive a move, which is of type move model. Technically, it could be undefined because you could not find it inside our valid moves, but we're kind of sure it exists. But just in case, we're going to allow it to be undefined anyway. And in our app, of course, we need to change this function here to accept this move. Now we update this, and now the move here can be used. That's it. Move type. If it's castle king side, castle queen side. With this in place, we're going to update the board, so update square piece with the rook that was in the other side. So if we are castling king side, we are looking for the rook on the king side, of course, so the rook on the column H. And H for us is 7. So I'm going to say here just const column, like a rook column. Let's call it here, like 7. And remember how we did the king column? So the king row, sorry, so king row, it is checking by the type, the color of the piece. So we're going to say here, move dot type. No, it's not the type, sorry. It's the piece dot color. If it's player color dot white. Oh no, I have a function for that, right? So piece dot is white piece, even better. then it's 0, otherwise it's 7. Simple like that. Rook column is in the column 7, so now we have to get here. Let's get it here. So board dot get square on coordinate. Which coordinate? Row, king row, just like we did before. And column, it will be the rook column. This is the square where the rook is on. Now, let's grab this piece here. So rook piece. That's it. And now we're going to update the square piece just like we did here. So what are the coordinates where we want to send this rook to? We want to send it to the row, king row, and the column. It's technically rook column -2, but for the queen, it will be rook column +3. So here, let's just say it right away. It's the 5. Okay, so we go 4. Here's the 7. Here's the 6. Here's the 5. So king goes to the 6. Rook goes to the 5. 0 to 7. That's it. And we're going to update it with this rook piece, which here could be null. Let's see why it is. Because it can be also undefined. Let me say, if there is not, I'm just going to say no. And now we're going to say board update square piece, row king's row, column rook column, so where the rook was previously, with no. This is, we change the rook of positioning. We just cannot forget that now rook piece dot set has moved through. This piece also has moved. It's not in its initial position. Okay? Let's go back to our application, to our board, and see if this works. If we move this here, the rook comes to the correct place. And that's it. That's the castling. Let's make the queen side, which will be very, very similar. And then, of course, we're going to refactor this. The rook column is 0, but all the logic here remains very similar. Just that the final column now, it will be the 2, if I'm not mistaken. Yeah, so, the 3 moves 3 to the right. Now we have it here. Let our dark king, and there you have it. The rook moves here. Now, if I select this king, it cannot move anymore. It's not in positioning of moving again, of castling again. But if I select the rook, they can still move as they could before. Like, no worries in there. Nice. That's the castling, the logic of it. But that's a lot of code, that's a lot of logic, and a lot of repeated stuff. So castle king side, castle queen side, they're almost the same. They just change the rook column and the final column. So I'm pretty sure we can refactor these and extract this logic into a common function. Let's create a new function here, which is const make castle move, make rook castle move, just to be quite specific. This will be void. It's not a pure function, unfortunately, but this is quite hard to make it as pure functions. So let's bring all of this here and see what we need. We need basically the piece. So here piece, it will be piece model. Can also be undefined, if I'm not mistaken. Yeah. And we need the rook column. And we also need the target column. So this is a number, and target column is also a number. Now we can remove this and say that the column here is the target column. Okay. Let's go back here and replace, put this here, make castle move, sending the piece, which actually here is not undefined. It needs to be correct one because it's this piece. That's fine. The rook column is 0 and go to the column 3. Now, this one here, actually, it goes to the column 5 and it starts in the column 7. That's it. Way, way better. Extracted, so we don't repeat this logic again. And the castling, both king side and queen side, they have a special notation for our move history list. And I don't know if you noticed, but we do have an issue here. It's always saying that we're capturing a piece. So it's always saying knight captured on f3, but we didn't capture any piece in this game so far, but it's still saying so. Even here when we did the castling, it said that the king captured. No, that's definitely not what happened. So let's take a look into this problem with the capturing, if the extra x appearing everywhere. And for that, I'm just going to first capture one, yeah, and see that even when capturing it appears. So it's really a problem in the logic. And now we do fix this, the capturing, and also add the specific notation for the castling. I'm going to start with the easy one, which is the movie history model. I'm also going to add here a type, like so. And now, whenever we create this, we say type, which is the type of the move. It's of course, the move.type. The move can should not exist because move can be undefined. So if not, it's just going to say that it's move type dot normal. If there's not like the move, it should always be there, but just in case, we're going to say that the move type is normal. And if the move type then is castle, queen side, or king side, we can use this in our move history in order to get the correct notation. So here I'm going to create a function, and here const get move notation. This move, of course, it will be a move of type move history model, and to return for us a string that we can use here in our HTML. Okay. Now, all of this technically needs to come here. No, not all of this, just this. So I'm going to create a new span here and say get move notation, sending the move, like so. Bring all of this inside and replace this DCX syntax we had before to a normal JavaScript. So we're going to return what? Piece notation. Then we're going to check if it's captured. Let's go here, const as capture. Let me do it slightly different actually. I'm going to do it here. Another one. If there's a capture, we're going to say X, otherwise just an empty string. Okay, so if there was a capture, okay, X, if not, just empty string. That's nice. And we finish it up with the column notation. Now it's missing something here. It deleted my row. Somehow it deleted my row, but okay, move to row. Remove all of this. Let's go back. See that still works just like before. Let's change it up a bit. Just check. Okay, it is still with the same error we had before, but the logic is working now in this function with the move notation. And now, before returning this, we're going to check if move.type equals move type castle king side. We're going to return O-O. This is the notation for the king side. Or then if move.type equals move type dot castle queen side, return O-O, like so. And if not, it's just a normal move or any other type of move. And now we just continue and go with our normal move notation. Let's try to castle here. Let me remove the bishops. I'm going to remove also the knights. And now I can castle here. Move notation. Perfect. If I do the same here, perfect. So both of them did the castle on king side in this turn. That's done. That was easy. Now, the not so easy part, find out why it's always showing as captured. My theory is that we're always setting this captured and it will always be there. So as if the final square piece here, the typing that is being sent to the capture, it's always being truthy. But we're going to come back here. I think it is in the movie history. So let's go in sources, go open here, move history, and put a breakpoint. I'm going to refresh our page. I'm going to execute one. See that in move, it's really hard with this one, but let me try to bring this up. The move that we have here, we have captured, we have a pawn, piece, pawn. Yeah, it's always being, even it's not meant to be there. So the theory is correct. Now we just need to fix it. Let's come back here to our app, and this final square piece, it already has because the board's already updated when we're checking this here. So I'm going to grab this target piece or captured piece from the final square. And now I'm going to send this captured piece here instead of the final square. Let me remove this, let it go. Now go again, and our movements now are correct. If I captured, there you have it. Perfect, that's fixed. With that fixed, and taking advantage of this current position here on the board, let's talk a bit about en passant. If you play chess, you know that the ability of en passant is a specific movement of the pawn that whenever they are in the row 5 or row 4 for the black, and one pawn adjacent on the adjacent column performs a two square movement forward for initial movement, we can capture this pawn and move to the diagonal at the same time. So the movement here, c6, would be possible. If you play chess, you know what en passant is. If you don't, I'm not the one that's going to explain everything to you. I'm not the best for that. Go quickly read something online. It's a very special technique, but as it's a valid move, we need to implement it in our code because, of course, it's part of the rules. Let's go back then to our code. Let's open an our pawn piece model. As a very specific move, just like we did with the king, we're going to add this movement here in the pawn. Okay, but this one doesn't depend on the current state of the board only. It also depends on the last movement done by the other player. So we need to receive here in our pawn piece model, in this get valid move, need to receive it the last move, which will be type move model. And of course, then we need to update this in our piece model. So we have move, last move, move model. And all the others, they don't need to be updated because different from some other languages, all these parameters and these functions here, these parameters of this function, they're not part of the function signature, okay? Just the name. So because of that, even if we add this here and not to the other ones, it is still the same function. Actually, if we add there, our lint will complain saying that let's show it. If I add it here to the rook and I add it here, it will just say that it's defined but never read. So our lint will complain. We don't leave it. We just add it here in the piece model and in the pawn because the only one that needs, at least as of now, and I think the only one that we really need because the other pieces don't have this special movement. This last move, of course, needs to be sent to our pawn piece model, and we're going to do that in the move service, as we have it here with get valid moves. I'm going to add it here, last move. This last move needs to be received, of course, in this get valid moves. So I'm going to say here move model. And in our app, or is it the board? No, is it the square? Where do we get the valid moves? Let me get here. Board. Yeah, it's in the board. We have here get valid moves. So our app also needs to send down to the board the movements, or at least the last movement, but I'm just going to say the full array so we can use it more if we need in the board. Send it down so the board knows the last movement to send here in these valid moves. So let's add it here. Let's say move history list, like so. And now in our board, and here I'm going to put it on the side. I'm also going to receive it here, so move history list to be an array of move model. I'm going to extract here this structure and the props. add to the dependent of the valid moves, and get the last one. How we can get it? We can simply go in the position, as it's an array, of length minus 1. Keep in mind that if the length is 0, we're going to be trying here to give a minus 1, which of course it's not valid. So what we're going to do here is dot length, send this, otherwise send no. In our move service, we need to adjust this last move to be or move model or no. And the same here can be or move model or no, because it can should not have had yet a movement, so that's completely fair. And here the same or no. This is what we have so far. Now our movement is coming to the Pompous model, and we can make use of it. I'm going to close everything else here, open just the Pompous model, so clear up a bit our ID. And here, so if it's white, we need to check if the row that the white is playing right now is the row 5, which for us, it will be the row 4. So because of 0 to 7, right? And we're going to do the same check here then for black. And now if row is equals 3, here it will be the same. I'm going to add here a to do, because we're going to first start with this one. And the idea here then is, if the other pawn is on the same row that our pawn and has other column +1 or -1, it's in one of the sides, right? So we're going to check here if the last move dot row is equal to 4 as well. Let's add this on the other for the black. So for 3 for the black. And now we're going to check if the last move dot column equals column, which is our column, our square, -1 to do, which we add it here inside. If the last move dot column equals column +1. So that's the idea. Let me add another to do here. If we're following my logic, we check if we are the row that we are is the 4, and if so, check if the last movement that was done was into the row 4, and also very important, if we are in the column to the left or the column to the right. I separate these ifs because only we need to send the specific valid move depending if we're going to which column, right? So I'm going to add here valid move. Let's just think of like a simple move for now. What we're going to push, what we have, it's a move model. So move model has a row, which will be the row 5 here, because we're checking the row 4, so I'm going for the row 5, while the column will be column -1. So it's basically the last movement column. We can just say it like so to be a bit more generic. And the type of movement is move type dot en passant, because we're going to need to verify this later. And now for the column +1, we keep the row 5, yes, and just here is the same. So actually, if it's the same, we can make this here. But didn't see that before, so now this will be here. And now this if inside if can just become one more if, so int this. This is the en passant for white. It's missing one detail, we get there, but I'm going to copy this here for black and change this value to 3 and 3, and the row here then will become 2. That's for black. Okay, let's go back to our application and see. No, it still doesn't work. I still cannot go here, so there must be something wrong with our logic. And I think I know what it is. Let me, yeah, movie history list. Yeah, that's exactly the problem. I'm trying to send, I'm receiving a move model, and I'm actually sending a movie history model, which is correct. I should be sending a movie history model. So I'm going to update this here, movie history model. Oh, it was too much. History model. Let's import this. Okay, that's fine. And now in our get valid moves, here the same to be a movie history model. In our piece, the same, move history model, import, and in our pawn, of course, move history model, import. And now we're not going checking the row. We need to check, let's move to row. So where it went to, here the same to, just to double check, here, dot two, and the same here, so dot two, two, and finally dot two. Let's move to dot column, and here the same, to dot column. Okay, where it went to. Now, this is fixed. This at least it's one of the problems that we had before, but now this is fixed. Coming back to our application, we still don't have it, but at least this error is done. As this is memoized and all, I'm going to refresh because I'm not trusting too much this. Our logic has a problem. I think it looks correct. So now I do the same movement, and now yes, I have it here, the option to go to this column and this row, of course. So our pawn from D5 until C6. That's really good. It's the implementation of the en passant. But before we trigger that on the board, I want to go back to the app.ts. And here, the same way we did the movements for the castling, we're going to check if the move type equals move type en passant. We're going to make en passant move, or remove pawn from en passant, something around this. Where we need to remove this pawn, we need to remove the pawn that was just en passant. So here, we need to remove the pawn on the row 4 or the row 3, depends. But we can just use the position of the new pawn, which is the same column, but if it's a white pawn, it will be the row -1. If it will be a black pawn, it will be row +1. We can just do this logic here. I think it will be simpler than to just like try to calculate everything. I'm going to create the function, const en passant. What do we need to perform the en passant? We need to know where is the pawn, which will be pawn column, number, and pawn row. Blacked out for a bit. Number. We can just rename it then row, column, right? This then, if this row and column, what we're going to do is basically board dot update square piece, row being row, column being column, and now, so this is the position, the piece we're going to send, it's now, we're just going to remove it. All that being said, it's just simply, we can simply add it here, right? No need to call a new function to do that. We just now need to calculate where is this row and the column. The column, as we said, it's the position, it's the final square coordinates. So here you say final square coordinates column, it's where we're going to. And the row is a bit trickier. I'm going to say here const row to be if our piece that we're changing is white piece, then the row will be final square coordinate dot row -1. Otherwise, it will be the rows +1. This is a function, so here, and now we can just send the row to here. This would make then that our en passant, when we transfer here, we're going to capture the other pawn. That's quite nice. It's working as expected. There's just one small flaw here still, is that in the pawn piece model, we are allowing for any piece that moves there. So if I move the rook here, for example, this if would still enter. So we're going to check if the last move dot piece dot type, or the piece is already type, perfect, is piece type pawn. And also really important, let's move dot color equals, in this case here, as we're playing white, player color dot black. So it's a very, very specific condition. As you can see here, there's a lot of logic, and it's exactly how an en passant works. It's a very, very specific movement. Let's transfer this to here. I'm going to say here now to be white, and the pawn also be the same. Why my lint fixed here and not there, I don't know, but let me then maybe do like this, and now it's fixed. This is the conditions for an en passant. Go back to our game. Let's try it a bit more. Going to play here with black. Put maybe the knight here. Going to put the black pawn here, and now use the white pawn here, so black can come here. That's exactly what is expected. Now white can perform here the capture. That's perfect. It's working as we want. Now you see that this is not in the same row, so it doesn't work the en passant. That's perfect. And that's great. It's a very specific move, but we need to get rid of it, right? Need to implement it. In the next video, we're going to do the promotion. So see you there.